So today we are going to talk about Git and like how you can get good at Git by knowing the model rather than the command. So it is well known that Git does not have the best interface. It has a lot of magical incantations that may seem confusing and not very intuitive. That is just because of the way Git was developed. It started off, it was supposed to be mostly a back end, and they were expecting other developers to hop on and make a new front end on top of that back end. But that never really happened. So we are stuck with the whole Git add, Git commit, or whatever that you may have heard of. Those of you who find that terminology new, don't worry. I mean, this is going to be very beginner friendly as well. So Git is a version control system, and this is, if I had to like summarize Git in a very simplified picture, it would be this, what you're seeing right now. You have something called your work tree, which is basically a folder. It's your file system, which contains your project. The workflow usually involves staging changes. That would be the git add command. So now this is where the Git part comes in. So Git has a portion called the index, which keeps a track of all your files in your project. And you make something called commits that creates a snapshot of your whole project state. So that's how you're managing your code and like your history, and that's how you're able to collaborate with people by like merging and combining these snapshots, and that's how people can work together. So enough theory, I will show you what I mean by that. So let's create a project, right? Suppose this was your programming project. What should I call it? I'll call it something extremely boring this time. Actually, no. I'm going for wet sandwiches. So this is a project. It's not a Git project right now. I should make one more directory in it called data. So in a very sophisticated programming project, there's going to be two files. Echo letter.txt. Oh wait, that's a number, isn't it? Okay, wait. Right. Just to check if that came out right. Cool. And number.txt. So right now we have two files here, but again, in a very sophisticated project, okay, is the font size better? I think I was getting a message on the Slack saying the font size was not big enough. I think this is better, right? So I have the thing, it's my very sophisticated project. It's not a Git project yet, but let's make it a Git project. So all you do is call git init. So you'll see initialized empty Git repository in my path to the project. So what is a Git repository, right? How do you know a repository is a Git repository? The simplest answer is it should just have a folder called .git. And this .git folder actually contains every single bit of data and information that Git needs to track your history. So that's your Git folder, and that's where all these data structures lie. So you would have something called commit objects and something called heads. So these two round things are heads. They are basically pointers to commit objects. That's pretty much all of Git, all there is to Git. Like there's no magic. So let's make one of these commit objects, shall we? So all you do is git add data letter.txt, git add number.txt. And obviously I could have added all of it by doing something called git add dot. That's like a shortcut saying add every single change from last time. If I see the status right now, no commits yet, but the index here knows about these two files. I've like staged it. So now I do something called a commit, and every commit has a commit message. So letter and number. So You do this and you get a bunch of stuff. You notice this. This is actually the way what identifies a commit. It's actually a hash of the data in the commit object. So over here, I would have commit number 1, number 2. That's a simplification. Replace this number 1, this ID, with a hash. And each commit object just points to the hash of the previous commit object. And now you'd be wondering, what is master and head really concretely? So as I said, every bit of information is in the git.git folder. So in fact, you would find out what head means if I just go to like the .git folder, head. So this is something you'll find in every single repository in Git. There's always a head called head in all caps. And it is actually a pointer that points to this. Now, ref/head/master. What is that? Let's find out. Refs, heads, master. And that is the hash of the commit object. So you notice the first few letters match up there. That is the same thing. So there's no magic going on here. That's pretty much all of Git. It is just a bunch of pointers to commit objects. And this master is the default branch that is created in Git. So in Git terminology, a branch is basically just another pointer to a commit. You'll understand it better as we start branching this now. Let's try that now, shall we? So suppose I create a new branch. So the way you do that is using a command called git checkout p. Again, these seem like magical incantations, but I'll let you know checkout just means move my head pointer to whatever I type out next. So in this case, it is move my pointer to -b, which is create a new branch. And I'll name this branch develop, because a lot of repositories, you'll see the development being done on like a separate branch, and master is like the main branch, which is like stable and sometimes used for releases or whatnot. So I switched to a new branch, develop. So if you notice, we would have created a new ref/head/develop. Where does that point to? Oh, wait. Right. There's nothing created on that branch yet, so it'll come soon. Let's see. But basically what we have done here is I have created a new branch called develop, and by default, the branch will be just pointing to whatever commit was there in the thing you branched it out of. And obviously, because I checked out to this new branch as well, head would be pointing to develop. So that's it. That's what happens when you create a new branch. So let's create another commit and let's see what happens to our data model here. Let's see. Echo. Okay, I hope this does not do some weird bash wildcard, but I think this should work. Echo star symbol.txt. One sec. Something is off. Okay, nothing's off. Echo. I don't know, usually my prompt has something that shows which branch I'm currently on. I think that prompt application stopped working, so never mind that. Anyway, when you are developing, you're not going to see that. So I just create a new file called symbol.txt. That should have been in the data folder, so I'll do that. Just move it to the data folder, and right, this is the state of our thing. So we have made a bunch of new changes in the work tree. So let's just say I've created a change. I'll mark it with a star because something's changed since I last did this. And if you've noticed, nothing's really happened to our index or any of our Git objects. Like Git will do nothing unless you explicitly give it the commands to make some change to the history, right? So for all it knows is your file system has changed, but like Git doesn't care unless you tell it. So as long as you're doing stuff, it has no meaning until I add it, right? So git add symbol.txt. Oh wait, data/symbol.txt, right? My bad. Git status, just to confirm, the index has found the new file. Let's commit. Add symbol. The convention is to write add present tense. So as you can see, a new commit object has been created on the branch like develop. So now to show the cat that I did that time, refs heads. That's where I was messing up. I didn't type that properly. So as you can see, this is the hash of the new commit object, which was this, which is just what I created. So basically what we have done when we committed the new change of adding a symbol, it created a new commit object over here on the develop branch. Let's add a square. Close enough. Commit number 3. Right, that's what's happened here. Okay, and this one points to the hash of the previous commit. So as you can see, this is now our branches have actually diverged. They're not the same, right? So what we are currently on is the develop branch, which has created a new commit object. This arrow doesn't look right. Yeah, that was slightly annoying. So it has created a new commit object that points to the previous one. And we have 2 branches, which are pointers to commit objects. And we have a head, which is where we are currently checked out on. That is the develop branch. So if I show you head again, that's just a reverse search. It's on the develop branch. If I suppose I check out to master and I show the head again, it's on the master head. So that's basically no magic going on. When I checked out to master, all it does is it moves my head and like points it to. Okay, I think that's how it worked. Yeah, it points it back to master. So a checkout is just point somewhere, right? So by this theory, if I can point my head to any pointer that points to a commit object, can I behave like these 2 heads where I can just point to any commit, right? Like just, can I do this? You can in fact do that. All you have to do is give it the hash. So let's look at git log. Letter and number. I think that's the very first commit. I actually, yeah. One thing about this diagram is I have 3 commits, but in my actual thing, there are 2 commits, right? So let's just some file. Let's just make a 3rd commit to make it match up, I guess. Git add some file. Git commit m some file. Right, am I on master? Yeah, I am on master. Actually, that'll cause a lot of chaos. Maybe not now. I'll get to that. So let's just assume we had 3 commits. If I had to check out a particular commit, I just have to give the hash of this commit. So git checkout and this hash. I'll actually get into that at the end when we get into the weird edge cases that trouble people. So for now, all you need to know is that it's a bunch of pointers to commit objects. So now to the more fun parts, or rather the more murky parts, right? Let's talk about merging. Now that's like the very first thing that is involved when you are working with other people. Often a common workflow is you create a develop branch, you add a new feature and commit this feature. In this case, let's say our new feature was adding symbols on our repository. So that would be this. Now your main release branch, your master branch, or for example, your stable branch of your project wants those changes. It's ready to take in those changes, right? So what you do is you take all the new things that was happening in develop and merge it back to your master. So master should now have everything that was done in develop. But let's mix this up a little. Let's make this a little more interesting because the real world is not so clean. Suppose in the time that uh, the developer, made this symbol change for in the develop branch, right? So if I go to git status, also I'll delete some file. Yeah. Right. So when I had added some file, it's noticing that in my work tree that stuff was there before. Never mind that. I think if I do git rm, it'll forget that I was ever there. But for now, it's just reset all the changes. I'm just running the command it has asked me to do here, git checkout hyphen hyphen some file. So it will discard all your changes in the working directory. So and right. So for now, don't mind that. All that was just for the sake of the tutorial. Just to keep things clean. I will explain that at some point, but let's assume I never did that whole sum file diversion, and we were very nicely and cleanly over here, and it's a perfect world. So you made the changes on develop, and in the meantime, some other developer who had also created a branch of master had pushed a new change. So something like this happened. Let's get a commit number 4. Right. And this was master now, right? Um, but for you, develop was still on commit number 3. So as you have noticed, merging this is not quite obvious. Like, so now if I switch back to main, and main would have an extra commit. So let's make that extra commit. So let's simulate that someone added like master. On master, they added a new commit, and we didn't know while we were working on develop. So here is where I make some file actually. And I don't care, it's not in the data directory, but it's fine. Git commit m psych some dev did something while you were on develop. I don't advocate making such long commit messages. It's a bad practice, but for the sake of this tutorial, I guess it should be fine. Now here's the thing. This is what our tree looks like. Now suppose the master branch wants your amazing feature of having symbols in the repo on your new commit. Let's move these a little up. So how do they get that new feature of yours, right? There needs to be some way of maybe making, I don't know, maybe this is a good approach of doing it, right? You take another commit object that is created, and you want changes from 3 onto this, right? Like this and like this, both of them should be in this, right? That's the ideal. So there is an operation to do something like that. It's called Git Merge. So suppose if we see our branches, we have develop and master. To do a Git merge, I just run Git merge. So what this means is Git merge develop onto the branch that I'm currently on. In this case, I am on master. So now it has created something called a merge commit. And this is actually a commit message opened in my editor, Nano, in this case, merge branch develop. So let's confirm that this is the commit message we want. Write out and exit. And as you can see, it has made the merge. So now what has actually happened here is we have a little graph over here, commit 3 and commit 4. And what it does is it traces the common ancestor of both develop and of master. In this case, the common ancestor is commit number 2. In our case, it was just one commit, but it finds that, and then it like steps through these and sees, okay, now I have to create I have to get all the changes from commit number 3 of develop into this. So it merges that into a new commit called commit number 5. And this commit will have the changes from both this one as well as like this one, right? So I'm just using this forward arrow to show that this has all taken all the changes from like commit number 3. Maybe I could decorate this arrow a little different, but let's just do that to avoid confusion. Okay, yeah, that works. So commit number 5 is a new commit created that has all the changes from 3 and 4. And I can confirm this by going to my Git log. Merge branch develop, that's the commit message. And this is the merge. And it actually shows a merge commit, which is created by merging the commit hash of this commit object and that commit object, right? And it has its own hash, which is to show that it is a new commit. And we can confirm, like, so this is actually belonging to this, and this is actually belonging to this. So that's what Git is actually doing. It's just manipulating these data structures underneath. So we have this situation, but let's create a new situation of merging, because not all merges actually create a new commit object. And this is important to know once we start talking about remotes. I will take like a 2-minute break just to see if there's any questions that you people have. Okay, I guess no questions. Anything you want me to repeat or anything? Nope. I think it's all clear then. Cool. So this is one kind of commit where you have like some change in master, and like it wants to pull in changes from another branch. In our case, it's the develop branch. And commit number 5 is created. And as you can see, it would have our symbols file. Their symbol, a new feature is included, right? So let's talk about another kind of situation. For that, let's create something called more symbols. I don't know. Cat echo. My bad. Beta slash more symbols dot txt. There you go. We have more symbols dot txt, and let's commit this. I'm lazy. I'm just going to add everything. And if you notice, if I add everything, it just stages everything that was there. In our case, this was the only change. So it's added to the index. And now I ask it to create a commit object from the state that is there in the index. So that is git commit m add more symbols. Actually, one symbol, but no need to be that pedantic. So as you can guess, what would have happened here? Just think about it, right? Cool, ding, 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 time's up. It created a new commit object, the same kind of thing, and it moved master. Oh God, that don't want that arrow. Bad arrow. There you go. And it told master to like point to this new thing. And head was on master the whole time. Phew. Okay. So that's our situation right now. And this is being very spastic right now. Don't mind it. Now, suppose I go back to developing another feature on the develop branch, right? So let's say I git checkout develop. So as you would have noticed, it's been a while. I'm a few commits behind. Like I'm on commit number 3, and since then 2 new changes have been made. That is the merge commit and this commit. So obviously, I want to stay up to date with like the main branch, like the main branch of like what's being released before I start working on my new thing. So maybe I should merge those changes onto this branch. So again, what I'm doing, to reiterate, I want develop to be up to date with the commit that master is pointing to. So git merge master. So that means merge the changes of whatever's on the master branch onto my current branch. And you would notice something different here. First thing, it did not ask me for that commit message in Nano, and now it says something called fast forward. If I see git log, there is no commit, there's no merge commit, right? Like when it's a merge commit, it's clearly labeled here, but here it just added more symbols, which was the thing I did that time. What happened here? Why is there no new commit? Any guesses? Okay, no guesses. I mean, I'm sure there are a few guesses, just that you probably thought of it in your head. So what actually happened here is our head, which was on develop, said I want the changes from master onto this new commit, like onto this branch. And it noticed that it does not have to actually create a new commit object. All it needs to do is just move this pointer over here and boom, problem solved. You're already up to date with the new commit. And I did not need to create a new commit object, right? So that's called a fast forward merge. The reason why this is relevant, why you need a fast forward merge is, if I were to push these changes onto my remote repository that is on GitHub or like any remote repository will accept a change only if the difference between your commit, like your whole commit graph, and their commit graph can be done in a fast forward merge. So maybe sometimes if you had worked on Git before, you'd have this thing saying it can't push because like the histories are not the same. You might have to force push it. That is because it couldn't do a fast forward merge. So that's another kind of merge that I showed you, and you'll see this often. It's quite important to know, if to understand why sometimes your pushes don't work. It's because it does not have the latest changes. So the fix to that is get your current repository up to date and then push it again. So I think that's basically covering merge. Let's go into now the weird territory, right? Like the parts of Git when I was initially learning that got me extremely bamboozled. One day I just want to like trace back to like a few commits ago when my code worked fine and not in the state I destroyed it right now with nasty symbols. So I just did git log and like, okay, I want to go back in time when things were simple and there was just, I had just added a symbol. There were no more symbols, there were no merges, whatever. So what I did is I copied this commit hash, which is what I'm doing right now. I did a git checkout. Oh boy, it gave a very messy message that I had no clue about back then, because all I had seen was tutorials that asked me to git add, git commit, git push, git pull, like enough to make me work properly with open source, but not enough to get me out of these weird situations. So what does detached head even mean? So as I mentioned, git checkout just means move my head pointer to something. In this case, it's this commit hash. So what I essentially did here is move my head directly to the commit object here. And the reason why it's called detached head is because this head is not associated with any branch. It's not pointing to another head. It's pointing straight to the commit. So if I make any, so that's why it recommends that I create a new branch if I want to actually make changes and preserve it. The reason is if I make a new change right now, it would do something like this. It would create a new commit object here. Commit number, I don't know, I've not been keeping a track. Commit number 7, there you go. So what it does is it points my head to this. This references the hash of the previous commit. And suppose I check out again with this head back to like develop, right? I would never be able to reach this commit ever again unless I specifically mugged up commit hash. Here it's easy to remember like 7, but I would have forgotten the hash at some point and it would have been lost. And if I lost the hash, I can never come back there because there's no name for this commit, which is why you need like a name to keep a track of every single commit object. The moment you don't have names, you're potentially losing a lot of data. So this is why you should never be in a detached head state unless you just, as they say, you just look around and make experimental changes. So obviously, the way to actually do the thing that I meant to do, which was I just want to go and like reset the state of all this chaos back to when it was just commit 1, commit 2, and I moved my head to like to point to master, which points to commit number 2. The command for that is actually called Git Reset. You have noticed I used it earlier back then to like get rid of some file. So in this case, it would be a Git Reset hard. And I type the commit object, which would be this. I'm not actually doing that because that would actually uh, ruin all the effort that I've done today during this workshop. What I can do instead is maybe create a copy of this whole folder and like show you how what it does. But a git reset hard is basically doing the thing that you really wanted to do, which is get your head to point to master, and this master would point to this. And right, the rest of the stuff is actually not gone anywhere. It's always in the .git folder. The way Git handles this is, suppose over time you have these weird dangling commits, Git actually has a garbage collector that gets rid of these commits once they get old enough. So for all your, like for your sake, whatever is named is whatever you care about, right? It's what you're actually going to work on and track. So that's what a Git reset does, hard. There are other modes of reset. So there's something called a Git reset mixed, which is actually the default when you type Git reset without any arguments. What that does is it just takes the changes in your work tree and I think, right, it doesn't mess with your work tree. It just resets your staging area. So anything that I'd staged back then gets unstaged and it's like back to like before I staged it, right? Another thing is Git reset soft. Actually, I think I'm mixing things up. So that's the thing about Git. It mixes things up. One of them just resets your index. Another just resets your work tree. Actually, I'll clarify that later on because I don't remember Git commands at all. Right. So that's one edge case. I'll revisit that at the end because I want to talk about the elephant in the room. Something you would have noticed. Our commit over here, which was merging, happened quite nicely because there were no conflicts, as in the two files were different. One was like more symbols.txt and another one just had symbols, right? So there it was a trivial commit. There is like a trivial merge. There was nothing new to do. And it was easy to just like throw everything together in the bag and create a new commit. But what happens in this kind of a situation, right? So let's simulate that situation. Right now, which branch am I on? Git status. Oh, right, I'm on detached head. So let's go to master. Right, on master. Let's go to our file called letters. And now I change this to B. Now I git checkout data slash number. Oh, wait, that was a goof. I didn't mean to check out there. Git checkout develop. Right. I think I accidentally created a new branch called data slash letter.txt. Yeah, so things happen in Git all the time, even to people who are really good at Git. That's what I've read from like experienced software developers and developers of Git themselves. But let's ignore that for now. I think Git, there was like something called Git branch delete. Okay, I don't think it created that branch. Anyway, it switched to branch develop. Let's make the second modification to letter.txt. Obviously, oh wait, I forgot to commit that. Whoops. Right, I did not commit that. Git add data slash letter.txt git commit m change letter. So that's the new commit. Now I can check out to develop. And let's make another commit here that does something else with that same file, right? So wait, I added before I made any change. Right, this one's still A because we had changed only the other one to B, but develop has not changed. So suppose develop decided that this line of code should be C. Now in this case, how does it, wait, let's add that again. Git commit m add change letter to C. Right. So now how does it commit? So let's recreate our situation over here, right? What develop branch did is create a new commit object, commit number 7. And this one is master also did stuff. Actually, this one should have been 7 because I did this one first. Either way, they're all hashes, so there's no ordering to it ever. This was the state of master. This was the state of develop. Both of them point to this commit. I like that more. So now, when I want to make a merge commit, it won't know whether to make letter.txt with the content B or content C, right? What would happen if I create the merge commit? It's going to create something called a conflict. So let's see what that looks like. I checked out to master over here. Should clear the screen again. Let's do git merge develop. And that's the scary message, conflict. So as you can see, the automatic merge failed. So in this situation, when Git doesn't know like what version to keep, it just asks the developer saying, hey, can you fix that, sort that out, and tell me what should be the new change. So if I see the Git status right now, it says you have unmerged paths. I can always abort the merge. So if I run into this conflict state ever and I didn't want to, I want to like go back to before I tried the merge, I just run this. So this is the thing where both were modified, data/letter.txt. And now what Git would have done is it would have added markers to data/letter.txt. This is what it looks like. So remember, on head is master because that's the branch we are currently on. If you see here, our head was actually on master, not develop. When I done the merge commit, this was what our tree looked like, our commit graph. And so head is master. On head, we had B. And this is like on the other side. So everything below these bunch of equal to signs is from the branch that you're trying to merge from, right? Like merge from develop. So develop had C. So now in this case, all you have to do is remove these markers. So I just remove this line and this line. Suppose I want to keep both, right? What I actually intended was that I want B and C to be in there. So like it's like kind of like I had a B and the C feature was also something I wanted. It just happened to be on the same line number because that's how Git diffs work. They are line by line. So this is the final version of the file. This is what I want it to look like. All I do is save the file. And now if I look at Git status, it'll still say there's a conflict going on, but I have actually fixed the thing because I've removed the conflict markers. So it says git add file to mark resolution. So I've resolved the conflict. It knows the conflict is resolved once by seeing that you have removed all the markers. So all I do is I add the file which had the conflict, which would have been data/letter.txt. And if I see git status again, that's it. All conflicts fixed, and I'm still merging. So I've what it's going to do is now it knows the contents of that file should be B and C, like both B and C. Now it can go ahead and create a new commit object. So this would be our merge commit. Cool. And this is a final result once I create the merge commit. So that would be git commit m merge conflicts is dead. So if I see git log, that's our merge commit. We have fixed the conflict and we can take a deep breath because that's basically all there is when it comes to conflicts. Whenever you have a Git conflict, all you need to do is remove the markers and you will be able to, so all you do is remove the markers, add it, commit it again, and you're done. This is what the final tree looks like. So, any questions? Can you try Git Ref Log? I believe it records every change made to the head pointer. Maybe that would store the. Yeah, so Kunal is correct. I actually do not know how to use Git Ref Logs. Like I think I had to use a particular flag or something. But what Git does is when I had like the detached head state, that is, I had created this random stray commit over here. I said I lost the commit because I have no clue how to get back to this, right? Unless I remembered the hash. But Git does have a feature in case you manage to royally screw up like that. It's called Git Ref Log. So I think let's just see how that works. Right. So what it does is it has a log of every place that the head has been to. So it will remember the hash. So I can always recover the hash for some time. So it contains when the tips of branches and other references were updated in the local repository. You know what? Let's just try Git Ref Log plain old because I think the best way to learn Git sometimes is to just try and see what happens. So let's see. This is the first time I'm doing this, by the way, but because you know how the Git commit graph works, you will be able to cope at anything new that Git throws at you. So as you can see, these seem like where the head used to be. These are different records of where the head had checked out. So if you've noticed, whenever I checked out from develop to master, or when I made a commit that moved the head somewhere, basically whenever the head moved, it created a record of this, right? So I'm pretty sure there's a way to like address this. Yeah, I think this is like the commit hash that you would get. So all I do is I move to that hash over here, and I should be able to recover my thing, I guess. This is what I understand from a cursory glance. Git Ref Log all. Let's try what he said. I think, okay, right. I think all just shows all of them. And my initial one showed till like 19. This one goes. I think it shows more stuff. It shows more stuff than the previous stuff. So there's something more advanced. Uh, in an ideal world, you should never have to use that if you have not done weird things like detached your head and gone back somewhere. I shall complete what I was talking about, Git Reset. So let's see. Let's get a refresher for what Git Reset was, because clearly I did not remember what was the difference between soft, hard, and mixed. Soft. So now that you know the terminology, everything should be easy to understand. That's the whole point of what I'm trying to get at here. Once you know the model, once you know Git is just a bunch of commit objects and hashes, and it has an index and a work tree, you should be able to understand everything, right? Almost everything. And like, you don't have to like remember commands. So soft does not touch the index file or working tree at all, but resets head to commit. So that would mean Git reset soft will leave this untouched. So whatever is there is same. This also untouched. Changes to be committed, but resets the head to commit, like all modes do. And mixed, changed files are preserved but not marked for commit. So that's what I said. Mixed unstages these changes and then resets your head to whatever you pointed to, like one of these commit objects. And the thing is, the difference between now, you might think like, what's the difference? But if it's moving your head, isn't that just like checkout? Not exactly. If I did git reset to commit number 5, it would move my current branch reference along with the head onto commit number 5. So that's a git reset. Meanwhile, a git checkout would have been this. That's a git checkout. And here you have reached detached head. So that's the difference. You're moving your branch and resetting it to a certain point in history. Like you're moving both of these there, right? That's the whole point of git reset, which is why I said that's the right command to do if you want to like travel back in time. So git reset hard discards both the index and the working tree. So if I had some changes over here, I had added some file here and I did a git reset hard, I would lose that some file, as well as I would lose whatever I added to the staging area. Mixed, I would not lose. Like basically, you can just look up this and figure out what works for your situation. There are 2 more modes, which I guess they're not commonly used, so I've not really heard of them. So that's Git Reset for you. 6:54. Okay, I think I was on time. I'll take a few more questions. Can you just brief once about indexes and work tree? Sure. Okay, so Anoop asks that like once like a kind of refresher on what these two are. Work tree is just your file system, right? So in my case, this is the work tree, just my files in like on my actual folder. That's work tree. Index is what Git considers like the staging area. So status index right now when it says working tree clean, it just means that there have been no changes between the index and the new work tree. Maybe if I create a new file, something. So like the index does not have this file, right? So the index is it's another work tree. You can think of it. It's yet another tree. Internally, it's implemented with some other data structures of its own called blobs and trees. But think of index as another work tree. But the difference is the this is tracking the changes, and this is where like this is what gets recorded into the commits. I hope that clears your question. Cool. Also, we'll be sharing again. We have like the resources for learning like Git from this point of view rather than the commands. I think we've shared them on the Slack before, but we'll share it again for good measure. Can always refer to that. It's more or less what I've said is covered in that in text. And next week, when we talk about it, we'll also get to the other harder parts, which would be stuff like remote branches. So often you would see something like Git Pull and Git Push, and that's like I'll just give you an idea of what that entails. So this is your local repository. Remotes is the concept of a remote repository is you have all of this, include that as well, but like a total copy of that over here, right? So this is your remote. So that is what you see on GitHub. And the idea of Git Pull is it takes the changes, the newest, it takes all these refs, which are these heads, and gets these heads over here, compares those versions of the head. So often your remote is called origin. So here it would be origin/master. And it like compares it with your head and does the merge accordingly. Again, that's for another meetup. But the idea is you have two different repositories and it syncs up the changes using pretty much the same mechanisms. Like if I'd shown how a merge is done between two local heads, it's the same with like remote heads, right? You'd bring the remote head here and it would have some new commit associated with it. And how do you merge this into that new commit? That's remote. So like again, you can just extend the idea of Git is a bunch of commit objects as a graph. That's the main idea, and that's how you're able to sync up your projects. And obviously, we have recorded this session. You can always refer to it. We'll upload on our YouTube channel. I know we didn't upload last week's because not all of it got recorded properly. And we thought anyway this topic was worth repeating in a better way. So there's that. I'm taking more questions till 7 and then we'll close. Oh, right. I promised that I would show what I meant by Slackbot. So we are actually making a new, like we're making a bot for our Slack workspace. Right now, we have not thought of much of the functionality. Mostly, I wanted to onboard new people who come onto Slack. And you just require like JavaScript knowledge, not any framework specifically. Probably Bolt.js, which is something Slack made specifically. It's not a lot to learn, but it looks kind of like this right now. Yeah, fluffy gold cephalopod. So maybe I'll make this into an open source project. You guys can actually work on it and stuff. There's like very clear and good documentation on how to use this. It's taking its own sweet time. So I can release the Slack bot as its own repository, and if you want, you can send PRs over there, and we can make that a thing. Right. This is the bot so far. It actually does work. It's there in our Slack workspace if you look it up. As of now, it just says hello to the user with a party parrot emoji when someone just joins the channel to which I have added the bot. I have not added the bot to the general channel yet because it's obviously not ready. But the whole point is it just reacts to things right now. So yeah, do let me know if you're interested. Merch link? I'm confused. If you okay, I see the message above there. If you're watching on YouTube, please like, share, and subscribe. Thanks, Nihal, for making me plug our own channel. Oh, and don't be like other YouTubers. Make good PRs for Hacktoberfest. Something legit, something helpful. Cool, it's 7 o'clock. Then I shall be ending. Thanks for coming, all of you.